All right, problem 6 from the 2015 Fourier response. We got we got let g of x equals 4 times x plus 1 to the negative 2/3, and we're gonna have f also be defined, not also, but f is defined as the integral from 0 to x of g of t dt for positive x values. Find f of 26. Okay, so then we'll just plug 26 into there. So f of 26 will equal the integral from 0 to 26 of g of t dt. So we just use this, differentiate this, find the antiderivative, and using the reverse power rule, we have negative 2/3 plus 1, 1/3 over 1/3. This becomes then 12. Then we're going to have the integral, or not the integral. We're gonna have 12x plus 1 to the 1/3 power from 0 to 26. So we're going to have 12 times third root of 27 minus 12 times the third root of 1. So it's just going to be, this will be 12 times 3 minus 12 times 1. So 24, because 36 minus 12 gives us 24. And part B, determine the concavity of the graph of y equals f of x for x greater than 0. Justify your answer. Okay, so remember with concavity, we want to analyze the second derivative. So we find the first derivative. Oh, you don't have to really even write y prime. We'll put f prime. The first derivative of f of x is going to basically undo this integral because differentiating and integration, differentiation and integration are like inverse operations, so to speak. So then we'll have this. But we got to differentiate again. So we're going to have f double prime is equal to g prime of x. So now let's look for potential inflection points. So we're going to set the derivative of g of x equal to 0. But first, let's take the derivative. Forgot that part. So g prime of x will be negative 2/3 times 4 times x plus 1 to the negative 5/3, which is just going to be negative 8 over 3 times x plus 1 to the 5/3. So let's set this for 0. Let's set this to, let's find possible critical or inflection points. So we want to set this to 0 and see what we get. All right, so cross multiplying, we'll have x to the, or x plus 1 to the 5/3 equals negative 8/3. And I mean, you could undo this, but if you can already tell that this is always going to be negative. The second derivative will always be negative, because there's no way to plug in the value that's positive into here. That won't be this. So I mean, well, let's just kind of finish it actually. Raising both sides to 3/5. Over x plus 1. Probably would have been easier if I did this after. Well, anyways, it just makes it even more apparent. Let's not even worry about the calculation here, because this is going to be a negative number, and it's going to be -1, so it's going to be negative. It's going to be super negative, not super negative, but it's going to be negative. So then it's going to be concave down. F of is concave down for all x or for x greater than 0. Concave down. Whoops. Don't write this messy on your test. This is just, helping you to find a solution. And part C, let h be the function defined by h of x equals x minus f of x. Find the minimum value of h on the interval from 0 to 26. Okay, so we want to find the first derivative, solve for critical values, and see where the smallest value of h would be. So let's rewrite this as h of x being equal to x minus, remember f of x is this thing. Taking the derivative of h of x, we'll get h prime of x will be 1 minus just g of x, because this will undo the integration, and let's replace g of x with what it with the expression that it actually says it is. So going back, let's write it as 4 times x plus 1 to the negative 2/3. Get some water. So set the derivative equal to 0. So 0 equals 1 minus 4 times x plus 1 to the negative 2/3. Add, divide, all that. So we get 4 x plus 1 to the negative 2/3 equal to 1. I mean, let's just look at it like this, I guess. Let's do 4 over x plus 1 to the 2/3 is equal to 1. Multiply, divide, so 4 is then equal to, I'm wasting a lot of room. I should have did this earlier. 4 is equal to x plus 1 to the 2/3. Take the third root of this, or cube both sides, and then take the square root. So raise both the 3 halves. So cubing 4, 64. 64 to the square root is just going to be 8. We have 8 equals x plus 1. And so then x will be 7. So this is a possible value that we want to check. Doesn't mean this is the don't confuse this with the minimum value. What we're going to do is we're going to check x is 7. And then also check the endpoints. X is 0 and x is 26. We're going to evaluate them into our integral. Where is it? Well, into here, I guess, because it'll be more clear. I mean, let me just write it out clearly. Let's first do 0, because that's going to be the easiest. H of 0 will be 0 minus f of 0. Remember, this whole thing is going to be just the x minus g of t or g of x. It's just a dummy variable, but we're just integrating from 0 to 0. So this will just be 0 minus 0. Because again, if you want to see it like this, we're integrating from 0 to 0 of g of t dt. So this will be 0. For 7, we're going to have h of 7 be equal to 7 minus f of 7, which will be 7 minus this integral from 0 to 7 of g of x. Looking back, g of x is defined as 4 times x plus 1 to the negative 2/3. We just evaluate this then. So we go h of 7. I swear I normally write neater than this. 7 minus, undoing this, which we already know what it is, because we've done it before, 12x plus 1 to the 1/3 from 0 to 7. And that'll be equal to 7 minus 12 times 7, or 12 times 7 plus 1, 8. The third root of 8 is going to be 2. So 12 times 2 minus 12 times the third root of 1, which is just 1. So 24 minus 12. So we have 12. 7 minus 12. So 7 minus 12 is just negative 5. And the last one, we want to find h of 26. And we'll get, so we will have 26 minus f of 26. Again, going back to this equation. Luckily, if you remember, going back to the beginning, we already did f of 26, which is 24. So we get 26 minus 24, giving us 2. So the minimum is going to be this value, negative 5. So the minimum is negative 5 when x equals 7. This occurs when x equals 7. You don't actually really need to write that, but you need to show your work and show what the answer is clearly. Okay, we're done with that one. That was tedious, but we're done now with the free response questions. So again, feel free to leave me comments, questions, good or bad. Feedback is always helpful. Always trying my best, but I am not the best yet. So yeah, feel free to to critique me. But also, if you did like it, give me some thumbs up, and make sure you subscribe. And I'll see you guys in the next video.